Hello everyone. So welcome to this lecture on ordinary differential equations, also known as ODEs. Okay. So the very first question is, what do you mean by a differential equation? So I think in the previous lecture we studied about numerical differentiation, and we also saw what is a derivative. Okay. So when you find an equation which is made up of derivatives of a known variable and unknown variable, that equation is nothing but a differential equation. Okay, so some famous differential equations that you actually encounter is, first, I hope you all know this equation. Okay, so if you write it down like this, so what is this equation? This is Newton's second law. So this is what a differential equation. So whenever you find equations, another equation, when you see, if you ask me, which I can recall at this moment, is this is Faraday's law. Okay, so this is also what a differential equation. So whenever you find equations which consist derivatives, those equations are known as differential equations. So what we are going to see here is, in this chapter we are going to talk about ordinary differential equations. Okay, so basically in this chapter what we are going to do is, we are going to solve ODEs numerically. Okay, now at this particular point you might be thinking why there is a need of solving ODEs numerically. So one thing that you need to understand at this point is, when you talk about real life phenomena, the equations that you get, the differential equations that you get are actually complicated and non-linear. Okay, to solve those kind of and the problem is, there is no analytical solution available to solve those kind of problems. Okay, so that is why what we do is, to solve those problems, we attack that problem by using the concepts that we studied, that is numerically. We attack that problem numerically. Okay, so if I am going to classify ODEs, there are a lot of ways of classifying ODEs. The very first method is based on the order of derivative. Okay, when the order of derivative is 1, that is known as, it is known as first order differential equation. When the order is second, it is known as second order differential equation. If you are still not clear, I can write down. When you find out differential equation where there is just a single derivative, okay, it is derivative of order 1, that is known as your first order differential equation. And when you find out equations which are of second order or double derivatives, those equations are known as second order differential equations. Okay, so this is one way of classifying ODEs. Another way of classifying ODEs is, one type of problem is known as IVP, that is known as initial value problem. The other type is BVP, boundary value problems. So when you talk about IVP, that is known as initial value problem, so in IVP initial conditions are given. When you talk about boundary conditions, initial boundary conditions are given, and when the starting and ending boundary conditions are given, that is known as your boundary value problem. So if I would want to write down this mathematically, I can write down that y dash is equal to f of x comma y. Okay, where this is my boundary condition okay, and x belongs to a. So this is my initial value problem. This is my differential equation, this is my boundary condition, and this is the domain of the problem. Similarly, if I want to write down a boundary value problem mathematically, I can write down that this is going to be y double dash xy y dash, where x domain is from a to b, where two boundary conditions are given and both the boundary conditions are at the end. So this is known as your boundary value problem. So this classification is very important for us, because when you talk about numerical techniques, numerical methods to solve ODEs, okay, you can classify them into two. One type of problem that you will encounter is BVP, that we have just discussed, boundary value problem, and the next is going to be initial value problem. So the numerical techniques to solve an initial value problem, are classified into two. First is known as single step method or single step techniques. The other is known as multi-step techniques. Okay, and if you want to talk about single step methods, your Euler's method, then your Rangakuta method. These are the methods that you are going to use to solve your initial value problem. Okay, so these methods are known as what? Single step. And when you talk about your multi-step, then there is Adams formula, Milnes formula. Okay, so there are a lot of other techniques as well, but we are just going to discuss these things. Okay, and when you talk about boundary value problem, we'll be using shooting method. Okay, so these are the techniques that we are going to see, or we are going to learn to solve your ordinary differential equations.